Hello, Luke. Welcome to Lesson 90. Today we'll be talking more about word problems. And again, we'll be dealing with word problems that have two statements of equality in them. In other words, there are two equations that we need to get out, and then we just need to solve that system of equations using the methods that we've learned. So I think the best way to get into this is just to start with a story problem. So, and actually, why don't you just read through this story problem and give it your best shot? See how you do. And then we'll do it together and see if you handled it correctly. All right, so the problem reads, together Charles and Nell picked 92 quarts of berries. If Charles picked 6 more quarts than Nell picked, how many quarts did each of them pick? Okay, this one should be pretty straightforward. So we have several things going on. We have quarts of berries that Charles picked and quarts of berries that Nell picked. So I think we need to start by defining our variables. That really should be the place you begin. And we'll define them as, well, let's call it quarts. We'll have the quarts and we'll put maybe a C here. Quarts sub C. This would be the quarts picked by Charles. Quarts picked by Charles. Okay, so there is one of our variables. The other variable will be the quarts picked by Nell. Q sub N. So that will represent quarts picked by Nell. And of course, these, in both of them, it is quarts of berries. All right, so there are our variables. We've defined them. Now we can start using those in equations. So we have this 92 quarts of berries. That's a total. That's the total amount the two picked. So right away, we should recognize that if we're finding the total amount picked, well, that's just simply the quarts of Charles plus the quarts of Nell. So the two of them combined should give us 92 quarts. So that should be one equation. So double check your work. Did that match with what you wrote? Hopefully it did. All right, so now we just need to find the second equation. And this is going to be the hardest part on almost all of these problems. There's going to be one equation that just kind of jumps out and is going to be really straightforward. And then the other equation is going to be a little bit trickier because they're going to use things like words like more than or less than or fewer than. And that can really throw you off. It's really hard to know where those numbers need to go. So, for example, reading this part of the sentence, if Charles picked 6 more quarts than Nell, how can I turn this into an equation? Okay, if Charles picked 6 more quarts than Nell, well, if we're trying to turn it into an equation, we have to find an equality. We have to find two things that are equal to each other. Now, clearly, the number of things that Charles picked and the number of quarts that Nell picked are not equal, are they? Right? We can't say that they're equal because it says Charles picked 6 more quarts than Nell. Okay? So how could we describe Charles's quarts, for example? Let's think of it that way. Quarts of Charles. How could we describe his quarts? Well, we could describe them as his quarts are equal to whatever Nell picked, right? They're equal to Nell's quarts plus 6, okay? Because Charles picked 6 more than Nell, okay? And watch out, because the temptation is to say, okay, Charles picked 6 more, so Charles needs to get the plus 6, right? Well, no, this is not accurate, because what we're doing here is we're taking the amount that Charles picked, and then we're adding 6 more to it. Okay, which is not what this is saying. This is saying you're taking Nell's and adding 6 more to it to get to Charles. Does that make sense? Because Charles picked 6 more quartz than Nell picked. So he picked everything that Nell picked plus 6 more. And that's what this first equation is saying. Charles' quartz are all of Nell's quartz plus 6 more. All right. So watch out for this. This is, again, I'm going to say it again because it's so important. This is the trickiest part to these problems, is making sure that you write the second equation correctly. All right. And remember, it has to be an equality. So this, whatever Charles is, we already know he has more than Nell. He's got 6 more than Nell. So this is some number. This number has to equal the right-hand side of this equation. And the right-hand side is the number of Nell's, and we add 6 to hers so that it equals the number of Charles. Okay? So make sure that that is straight in your head. That's, again, the trickiest part to this whole problem. So let's write that down over here. So we have Charles's amount. So the quartz picked by Charles, that is equal to the quartz picked by Nell. Whoops, did that wrong here. Oh, I did that wrong up here too. I'm sorry. This should be quartz of Nell up here. I'm not using my variables. So the quartz of Charles are going to equal the quartz of Nell plus 6. Okay? All right. And then at this point, it is now just a system of equations. The rest of this should be easy to do. You've done this so many times at this point. You can use elimination, you can use substitution, whichever one you'd prefer. Looking at it, I think this one really offers itself to substitution because you have already one variable set out by itself on one side of the equal sign, right? So it's pretty straightforward to plug this q sub n plus 6 into this q sub c up here. All right. And then you would work this out the way that you've been working them out all along. So again, I'm taking these problems directly from your textbook. So you can find them in there as well. I'm not making them up out of my head. In your textbook, they get you to this point and then they say, go for it. The rest you know how to do. And I think because the setup is what's so important here, I'm going to do the same thing to save time. So we could solve this together, but I'm going to assume at this point that you can solve this using elimination or substitution. All right? The setup is what's important today. All right, so let's try another one. And again, just pause the video and try to get the setup right. You don't need to solve the whole problem, but at least find the 2 equations, and then we'll make sure that you got those right. Because if you get those right, chances are good that you will know how to do the elimination and the substitution following that. So pause the video, give this one a try. All right, so it says the number of boys in Sarah's class exceeded the number of girls by 7. If there were a total of 29 pupils in the class, how many were boys and how many were girls? All right, so we have boys and girls. So this one should be almost, really easy. We've got, I think we can even just use the B. I don't even think we need a subscript here. Let's just use B is going to be the number of boys. Well, you know what? Let's use a subscript because we are really looking for the number of something. So we'll go N for number and then B for boys. So this would be the number of boys. And then we'll do the same thing with girls. N sub G. That'll be the number of girls. All right, so there we go. We've gotten that taken care of. Now we can find our equations. So the number of boys in Sarah's class exceeded, meaning there's more boys than girls, the number of girls by 7. So let's think about that. The number of boys in Sarah's class. So N sub B. How could we describe N sub B? It exceeded the number of girls by 7. So what does that mean? It means that as many girls as there are that many boys. In addition, there are 7 more. Okay, so there are as many boys as there are girls. In addition, there are 7 more boys. Okay, so the number of boys is going to equal all of the number of girls. It's going to equal the whole number of girls, right? Plus 7 more. All right? Does that make sense? The number of boys in Sarah's class, the number of boys right here, what did it equal? It equaled all of the number of girls, all the girls, plus it exceeded them by 7. So it's plus 7 more. All right? So that is our first equation. Again, that's probably the tricky one. Let's go on to the next equation. If there were a total of 29 pupils in the class, how many were boys and how many were girls? Well, this one is pretty straightforward. So they're total. So there's a total of 29. So how do we get to the total? Well, there has to be a sum over here. What are we adding? We're adding all the pupils, which would mean all the boys and all the girls. So this is simply going to be the number of boys plus the number of girls, right? And there we go. We have our two equations in two variables, so we can solve this. And again, you'd use elimination or substitution, whichever you prefer, to get to the solutions for this. All right? Excellent. All right, so here's another one. Go ahead and pause the video, and again, just get the setup for this, and don't worry about the actual solution at this point. All right, so it says Philip cut a 38-meter rope into two pieces. The long piece was 9 meters longer than the short piece. What were the two lengths? All right, so let's get our variables taken care of. So there are two lengths that we're talking about here. So I'm going to call it L, and then we'll go L sub S for, the short length. And then we'll go L sub L for the long length. Okay, so there are our variables. That part is done. Let's find our equations. So he cut a 38-meter rope into two pieces. Now let's think about that. If he has a 38-meter rope and he cuts it into two pieces, well, wouldn't that mean that the short one and the long one added together must sum up to 38, right? So that would be one equation. The two lengths have to sum to 38. So we have the length of the short plus the length of the long. They have to equal 38. So there's one equation right there. That one's pretty straightforward. Now we have the tricky one, right? So the long piece was 9 meters longer than the short piece. So it starts by talking about the long piece. So let's just write that, the long piece. And what are we saying about it? It is, equals. Long piece. Remember, was and is usually means equals. So the long piece was 9 meters longer than the short piece. Okay, so it was all of the short piece, right? It was all of the short piece. In addition, it was 9 meters more than the short piece. So it's going to be the length of the short piece plus 9. Okay? And there we go. That is our system of equations. Right there. That's, again, a nice one set up for substitution in this case. Okay, very good. Moving on. Let's try this one. Go ahead and pause the video and try this one. All right, so it says the sum of two numbers is 72. So right away we see sum. There's addition going on, right? We have two numbers, they're being added together, and that's going to equal 72. The difference of the numbers is 26. What are the numbers? So we're talking about numbers here. So we're just going to call them, number one. N sub 1 will be the, it doesn't really matter. We'll just call it the first number, I guess. Or we could call it the, one number, and the other be the other number, the second number, but N sub 2, we'll just call that the second number. Okay, there. Okay, so there's our variables, N sub 1 and N sub 2. And we're saying the sum of the two numbers is 72. So the sum, again, indicates addition. And what are we adding? We're adding the two numbers. We're adding N sub 1 plus N sub 2. And then they tell us that that is, which remember is equals 72. So very easy, very straightforward. The difference of the numbers is 26. Well, in order to make sense out of this, we need to remember what difference means. In mathematics, difference is the solution to a subtraction problem, right? So if it's the solution to a subtraction problem, we're talking subtraction here. So just as their sum is the addition, their difference is the subtraction of the two numbers. So we're going to have n sub 1 minus n sub 2 is equal to 26. What are the numbers? Okay. Well, here we have our two equations now. So we could go ahead and solve this, right? Excellent. One thought on this, as I'm just writing this out, because they used the difference. In addition, it wouldn't matter. So what I'm thinking of is one of these numbers is, unless they're the same number, which is probably not likely because if you were to subtract the same number, you'd get 0. So they're different numbers. And one number is going to be a bigger number, and one number is going to be a smaller number. Okay? And if we add a bigger number with a smaller number, we'll get 72 in this case. That's not a problem because it doesn't matter which one is bigger, which one is smaller. If, let's say, n sub 1 is bigger, let's say it's, 35, for example. I'm just picking a number here. And then n sub 2 is, what would that have to be? A 37, right? So if n sub 1 is 35, n sub 2 is 37, I could say, yeah, and 35 plus 37 is 72. That makes sense. In fact, I could do this the other way around too. If n sub 1 was 37 and n sub 2 was 35, it would still be 72. There wouldn't be any difference here. We can flip-flop these two numbers and nothing happens in addition. However, in subtraction, things get a little messier in subtraction, okay? Because if I have two numbers that are not the same, it's going to matter which one I write first, right? Because if n sub 1 is bigger, if that's the bigger number, well then I'll have bigger, minus smaller, which is going to produce a positive answer, right? Something bigger minus a smaller number is going to give me a positive answer. But if I switch these around and write it as the smaller one first and subtract the bigger from that, think about what's going to happen here. I'm going to end up with a negative, right? If I have a smaller number and then I subtract a bigger, like, if I have a smaller number, let's say I have a 3, and I subtract a bigger number, say a 5, well, I'm going to end up with a negative number, negative 2 in this case, right? So the point being here is it does matter, actually, which of these is bigger and which is smaller. So I think what I might just do is I'm going to kind of clarify this. And I'm going to say n sub 1, I won't make that my first number. I will make that my larger number. Okay? And then n sub 2, I'll make that my smaller number. That way there's no confusion. And then that way, when I come into the second equation here, the difference between the two numbers, which again is the subtraction of the two, I'm writing the bigger number first. N sub 1 is the bigger, minus the smaller, equals 26. Okay? So that's one thing that I probably should have done in the beginning, but I didn't think of it until I saw the second equation, which was stating the difference. Okay? And we want the bigger number first. Hopefully that makes sense to you. All right. Very good. Then let's, moving on here, let's try another story problem. So go ahead and try this one on your own, and then we'll do it together. All right, so the greater of two numbers is 16 greater than the smaller. Okay? When added together, their sum is 4 less than 3 times the smaller. What are the numbers? Oh my. So here we've got all kinds of things going on. Well, let's break it down. We need our variables. So we'll have number, and I think I'm going to use a similar notation, maybe a little bit more specific though. So we'll use number sub s, and that way we can kind of get what we didn't do before out of the way in the very beginning here. So n sub s, that's going to be the smaller number. Okay, that'll be the smaller number. And then n sub l, we'll make that the larger number. There, just so that we're clear in case there's any subtraction that might be going on. Okay, or division for that matter. So, all right, let's see what we've got. So, the greater of two numbers, so the greater, that's the larger, that's n sub l. So n sub l is, well, that would indicate equals, right? So the greater of the two numbers is 16 greater than the smaller. So again, think of this in terms of the larger number is everything that the smaller number is, and in addition, it's 16 more. So it's all of the smaller, n sub s, all of the smaller, plus an additional 16. That is what n sub l is, the greater number. Okay? All right, so there's our first equation. Now, when added together, oh, all right, so we're adding these together, right? We're adding the n sub l and the n sub l. Or, I'm sorry, the n sub s plus the n sub l. We're adding them together. When added together, their sum, this is their sum, is 4 less than 3 times the smaller. Well, again, we've got this is here. So this sum right here, that is equal to 4 less than 3 times the smaller. All right, so let's kind of just ignore this 4 less than and this 3 times then, and just look at the smaller. So the smaller number plus the larger number, it's going to be equal to the smaller number, n sub l, but not just the smaller number, it's 3 times the smaller number. So it's 3 times n sub n. And it's not just 3 times the smaller, it's 4 less than that. Okay, so it's 4 less than 3 sub n sub s. So we have to subtract, a 4 from this. All right, is that clear to you? Make sure that it is, because again, this is the trickiest part to these problems, is getting this down. So we have their sum, and it says that that sum is, meaning equals, it's 3 times the smaller. That's what we have here, 3 times the smaller, but it's 4 less than that. So we have to subtract 4 from that. Okay, does that make sense? All right, and then that would be our system of equations, and we could solve it from there. Okay, excellent. Let's try another one here. Hopefully by this point you're getting these down, but if not, keep working on them here so that you can get them down for your seat work. So why don't you pause the video and try this one on your own, and then we'll do it together. All right, so this is an interesting one because here we're talking about ratios, okay? And we're going to have to kind of dig back into our memory bank and remember how to work with ratios, and in particular proportions, okay? So they're saying the ratio of two numbers is 5 to 4. The ratio of two numbers. So we're dealing with two numbers, and that's what they're asking for in the end. What are the numbers? So we have two numbers. So again, we're going to give it, one is the smaller number, n sub n, smaller number, and then n sub l will be the larger number. Okay, there are our variables. And now we're saying there's a ratio. Remember what a ratio is. A ratio is simply a fraction. It's a comparison of two things. Okay? And that fraction, or that comparison of these two numbers. So it's a ratio of two numbers. So it's of these two numbers. So it's a ratio of those. So it's n sub s over n sub l. That is a ratio. That is a ratio of the two numbers in question. Okay? Ratio just means a fraction. Don't let it throw you off. All right? This ratio, what are they saying? It is. What is is? Is the equal sign, right? 5 to 4. So that's the ratio that these two are. This variable ratio is. So it's 5 to 4, right? Okay, so that's one equation right there. And the sum of the numbers is 63. That's the second equation. The sum of the numbers is 63. So we have to add the two numbers together. So n sub s plus n sub l is equal to 63. So these are our two equations. I might take this one step further, though, because this ratio may be kind of throwing you off. Remember how to kind of work with these. This would be considered a proportion because we have two ratios that are set equal to each other. And remember, when you have a proportion like this, you can do that cross multiplying that we learned quite a while ago. And that would indicate that you can take the top number and multiply it by the opposite lower number. Okay? So this n sub s, we can multiply that by the 4. That is going to give us 4n sub s. Okay? And then we have our equal sign. And then we take this 5 and we multiply it by the n sub l, and we get 5n sub l. Okay? And once we have it at that stage, it should look a little bit more doable for us. So now we've got this lower one is n sub s plus n sub l equals 63. There is maybe a little bit of a nicer version of these two equations, okay? And maybe a little bit more solvable for you. I think for me, I would probably think about using, well, you could go either way. If you try to use substitution, I would probably use the second equation to solve for the n sub s or n sub l, and then plug that into the first equation. Might be the easiest way to go. Otherwise, you could, do some elimination here as well. That would also work. So, but anyway, so that is the system of equations for that particular problem. I think that might be the last one I have. So since it's the last one that I have for us here, and we have a little bit of time, let's just go ahead and solve this one the whole way. So, as I said earlier, let's think about how we want to do it. We can use elimination or we can use substitution. I might use substitution on this one because I just feel like you can take this second equation and very easily solve it for n sub s, okay, by just moving this n sub l, over to the other side. So n sub s is going to equal 63 minus n sub l, right? And then knowing that, I can now plug that into this top equation. So the top equation then becomes 4 times n sub s, which we now know is 63 minus n sub l, equals 5 times n sub l. All right, then we can use some multiplication here to distribute this through, and we end up with what, 252, I believe, minus 4nl equals 5nl. And then just to keep positive variables going here, or coefficients going here, we'll just move the negative 4nl over to the other side by adding it to both sides. That's going to give me a 9nl on the right side, and I still have this 252 on the left. And then I can divide both sides by 9, right? So I divide this side by 9, and I divide this side by 9. These will cross out, so I end up with n sub l is going to be equal to 252 divided by 9, which is what? 28. So we have n sub l is equal to 28. And then we can solve for n sub s by plugging this into here, right? So we have n sub s is equal to, n sub s plus n sub l, which is 28, is going to be equal to 63. And now we just subtract the 28 from both sides. We get n sub s is equal to 35, right? 35. So that is n sub s. So those are the two numbers in question. Their sum is equal to 63, and the ratio is 5 to 4. In other words, if you put these two on top of each other, 35 over 28, that's the ratio, that can be reduced. All right, that can be reduced by 7. 7 can go into 35 5 times. 7 can go into 28 4 times. So it reduces to 5/4, which is what the ratio is supposed to reduce to. So we know we did it right. Okay, so there you go. That's one problem anyway that we solved in full. The others, we just worked out kind of the setup, but the solution is what you've been doing all along, just elimination or substitution. All right, very good. So good luck with these. Just kind of slow down and put your thinking cap on, and make sure that those equations are making sense. Okay. Again, that's the trickiest part, is just making sure that you write down the correct equation. All right, we'll stop here, and I will see you tomorrow.